Alright, in this video we're going to talk about Unit 2, Objective 12, the derivative of polar functions. So if you watched that short video on polar functions that I linked on the website, you know that polar functions are going to be written of the form r equals some function of theta, where r is going to represent the radius, how far away from 0 we are, and theta is going to represent how far we've traveled in the counterclockwise direction from the positive x-axis. So r equals f of theta. In order to do the calculus with polar functions, though, we're going to need to treat it like parametric functions. So we're going to need to write these things in terms of x and y instead of r and theta. So to do that, we need to use these following conversions, and we need to have these things memorized. So x is going to be equal to r cosine of theta, and y is going to be equal to r sine of theta. Now, r is just going to be this function here. So when we go to take derivatives, we're going to have a function of theta times sine of theta, a function of theta times cosine of theta, and that's going to introduce the product rule every single time we take a derivative of a polar function. So polar functions, just like when we were doing parametric functions, dr d theta is going to be equal to dy d theta divided by dx d theta. So we're going to want to take the derivative of the y piece, take the derivative of the x piece, and divide them just like we did with our parametric functions. So let's take a look at a real quick example. Find the slope of the function r equals 2 theta when theta equals 3 pi over 4. So to do that, we got to think first. We can't just jump in and take a derivative, right? Slope means derivative. We have to think in terms of x and y. So we need to come up with x equals r cosine theta and y equals r sine theta. Except they told us right here what r is. So x equals sine of 2 theta cosine theta, and y is going to be equal to sine of 2 theta sine theta. Now, we can't make this sine squared because this is a 2 theta and this is just a regular theta. So this is that product rule that I told you is going to happen every time. So r is sine of 2 theta. We plug that in. To get the dx d theta, so the derivative of the x portion, we got to use that product rule. The derivative of sine of 2 theta is u prime cosine u, where u is that 2 theta. So the derivative of 2 theta is 2 cosine 2 theta times cosine theta plus the derivative of the second one, so negative sine of theta times sine of 2 theta. And dy d theta is going to be, so the derivative of sine of 2 theta is still going to be 2 cosine 2 theta multiplied by sine of theta. And then plus the derivative of sine is cosine of theta times sine of 2 theta. Just notice I left my theta off there. So dy dx, so the slope of our function, is going to be this y derivative, so 2 cosine 2 theta sine theta plus cosine theta sine 2 theta over 2, the x part, 2 cosine 2 theta cosine theta minus sine 2 theta sine of theta. Now we want to evaluate that, so at 3 pi over 4. So this little bar right here means evaluate at this point here. So if you plug 3 pi over 4 into all of this stuff here, you get 1. So the slope of that function is going to be 1 when you plug 3 pi over 4 in. So that's going to do it for this video. We'll see you in the next one.